up, guys? Welcome back to another video with the Math Maker. My name is Jordan, and today we'll be talking about types of triangles. I wanted to add triangles for my next lesson because of how angles are usually used. Angles are usually used to describe type of triangles. Like I have already told you about. I already told you about the right angle triangle. I already also told you about the obtuse and the acute triangle. So those are all types of triangles that there are, but you have to find the right angle. So I put in for my angle, you usually have to use a protractor. I had to get a protractor for my next video or the video after that. I know I said I was going to get a protractor. I am. I just don't think it's time to get a protractor for this yet. I think it's better if I get a protractor for when I add both the angles and the triangles together. So then this is what a protractor would look like. Sometimes you would have something right here, and then that thing would have a little triangle in the middle. So to see if it would be 90 degrees, this would be 90. Oh, that's a horrible 9. That actually looks more like a P. Since I don't, I'm trying to write as small as I can so I can get a lot of the numbers. 90, then it would go back to 80, 70, and it would keep on going. But of course, the numbers on the protractor would be a lot smaller than that. The protractor is actually smaller than what that looks like. But then also, this side will go 90, 100, 110, and it would just keep on going. So, very important part, like I said, is if it's bigger or smaller than 90. Because if you do this way, if you want to make a triangle right now, you go down, straight at 90. Triangle, triangle. So you just made a triangle. And there's actually a certain type of name for this triangle. It's right here. Right. So it's actually called a right angle triangle, or you can just call it a right triangle. Many people just say right because they kind of know that right is for the right angle triangle. The reason it's called that is because it's angled to the right. And you can also tell, because if you see here, I put a small little square right here. So you can tell that it's a right angle triangle if you're able to put at least a small amount of the square. 1, 2, 3, 4. And that's how you can tell, because you made a perfect square with the thing. I know my thing looks more like a rectangle, but it's supposed to be a square. You can't make a square on this corner because it's not even. 1, 2. Now that would be more or less a trapezoid. So that wouldn't be even. And when you have a right angle triangle, you only have one angle that's actually right. So that's what most of the time protractors are used for. They are used to tell if something's obtuse, which means it's bigger than 90, acute, smaller than 90, or right, which is exactly on 90. So then, let's say we're working with something kind of obtuse. So you wouldn't have all of the same things. I'm actually going to use kind of the same example I have there. So yeah, that. Let's say we're going to 110 now. So then the angle would go all the way right here. So then you have that part of the triangle, that part, and then this part. And those would be the parts of an obtuse triangle. One part of the triangle would be bigger than 90. Because we all see that it's too big to form a perfect square or triangle or whatever you call it. So there's no way that that can have a right angle, because the square would be too big and it would be uneven. So for this, you would just nose is obtuse. Also, if you had a protractor, because that's what this is supposed to be called. Like I said, I will get another one. I will get an actual one for my second to next video. So then you can see that this is bigger than 90 because it's not a straight right angle, and that it's past it, so that's obtuse. But one more thing, if you never noticed about the 90 and the obtuse, is that after that one angle that has been changed, the rest of the angles are acute. And I'm going to get to that right now and explain what I mean. So now, acute angles are angles is an angle that is less than 90. So let me show you a picture. So let's say we're going to 80 instead. Arrow points there. So then you would go back to the square. This is also kind of close to an equilateral triangle. But in this case, look, to have an acute triangle, it's not that you have to be lower than 80. All the 90, all the sides must not be a right triangle. See, I can't make a right triangle. I can make a square, another triangle. Because for a right triangle, you should be able to make a square. Like that, or like in that picture. But for a acute triangle, you cannot make a square or rectangle. You can only make kind of a weird triangle. So that wouldn't work out. So all of these wouldn't be really good. Because when I mean that, you would not have a complete right angle for it. So that's how you can tell it's an acute angle on the thing. So now we're gonna erase the protractor, because for the next ones, this is something you can just kind of tell how it's happening and why it happened. So let's say we're gonna go straight to equilateral. So we erase the protractor because that's not needed for these anymore. This is, okay, how much do you know about your triangles, more or less? So an equilateral triangle is a triangle with the same exact length on each side. So for this, you have 1, 2, 3. Every single side is the same length. Not on here, it might not be, but on an equilateral triangle, it's supposed to be the exact same length for each side. Like how a square is exactly even, that's what the equilateral triangle is supposed to be. So this actually isn't perfect. We can actually use this one for a scalene triangle. So we're actually going to switch to scalene because this isn't perfect to the T. So for a scalene triangle, none of the sides can be the same length. So if you kind of look closely, you can tell that this side is bigger than this side, but this side is also bigger than this side. So none of the lengths are equal. They're all different sizes. So that's how you can tell it's a scalene triangle. To tell it's an isosceles triangle, you must have at least 2 sides which are exactly equal. So that would actually not be, because this would be equal to an equilateral. So to have 2 sides that's exactly equal. These 2 sides are exactly equal. There is no extra, nothing to it. The 2 top sides are exactly equal when the bottom side is a different size. So these are equal. So that's how you can tell it's an isosceles triangle. Now to tell it's a equilateral triangle, every single side must be exactly the same length. So I'm gonna kind of measure this out in my head. It's that perfect triangle you always see everywhere, but you know it's really hard to draw for some people. So as you see right here, every single length is the same. Every single one of them have the same length. So that's how you can tell it's an equilateral triangle. So to also tell, so now another way to tell that you have a right angle triangle, or to even make a right angle triangle, is if you make a rectangle and you cut it right diagonally in half. Now you have one right angle triangle, two right angle triangle. Now if you make a square, if you cut that in half, that could also work. It would do the same thing. And then make the same right angle triangle. So I hope you guys learned something today. Please do not forget to also like and subscribe if this is one of your first time watching any of my videos. Tap the notification bell if you want to get more updates when I post more videos. Comment down below if you have any questions or if you want me to do a certain math video. Thank you for watching and have a wonderful day.